Hello, my name is Arthur, and in this video I said we would come back and look at how to create the graphic for this isometric tank turret. So we'll just have a look at what the tank turret does, and we'll get an idea for how it works in general, and then get more specific later. So right now it's able to aim towards the player's soldier character. And that's accomplished through an animation that's an animated sprite graphic. So we'll look and get an idea for how that works. So there's an extra piece on this that I haven't put onto the soldier character, and what it is the muzzle, which is a position 2D, or yeah, position 2D node. This aspect of doing a gun that rotates in isometric, this is a fair amount of work because this location has to be tracked for each and every animation. And the same needs to be done for the player. The actual muzzle point that a bullet or a muzzle flash is going to come from has to be animated. So it has its own animation player with a series of animations that matches up with the animation frames of the turret. So we'll start off looking at the turret and the animation, and then how to get that working with an actual muzzle later on. But the muzzle aspect of this type of a graphic is a fair amount of effort, particularly because I used a fair amount of frames to create the rotating turret graphic. So this is the animated sprite frames, and how it functions is basically there's 36 images that represent 10 degrees of rotation per image. And the image sequence starts at what in Godot would be a 0 rotation. So it's pointing at a 0 rotation. Whereas at frame 18, we can see the graphic is pointing with 180 degrees of rotation, or frame 18, which is 18 times 10. The same holds true for any of the angles. 270 is a right angle pointing up, and 9 is 90 degrees, a right angle pointing down. So that's how the frame, the animation is structured, so that the frame number can reflect the rotation of the graphic. Let's have a look at the script for the turret just to get an idea how it works. And I'm not the best person for teaching scripting, and this isn't the greatest piece of script or anything that we're ever going to see done for Godot. So let's get that out of the way so we can just see the script. Yeah, you're going to need to know how to do scripting. I'm not the person to teach that. I'm a person learning that myself. So the script isn't properly broken down. It should actually be broken down into some different processes. But I'm just really getting the animations working so they function. Now, how this animation works is the turret is a separate piece that's attached to the tank. So it receives its target from the tank. And the target is the body of the intruding enemy. So in the demonstration that I gave, it's the soldier character intruding on the tank's vision radius. So it receives the body, the kinematic body of the soldier. Function process continually updates the variable frame with the current frame of the animation. So it's a number between 0 and 35 to represent the different angles. When an aim target has been set, so the aim target no longer equals null, the node 2D that's attached to the animated sprite will look at the global position of the target. Now, by sending the kinematic body to the turret, It's constantly able to track it as long as it's within its visual field. The node 2D is used to determine the angle to the target. And this is done as an integer because we want the angle to round off. In the end, we want it to be rounded off to a nearest 10, basically. The next four lines take that angle and convert it from a degrees that ranges from 0 to 180 on one side of the circle and minus 180 to 0 on the other circle. These four lines turn that into a 360 degree circle so that it's 0 to 359 degrees. That angle is then divided by 10 to result in a number that will match up with one of the frame numbers. The rest of the script determines which direction the animation should play in. So if the frame is greater than the angle, animation direction is true, and that means that the animation will play in reverse. Or if it's less than the angle, it will play in a forward direction, so reverse is false. These four lines stop the animation from taking the long way around. So if the turret is on 10 and the target is on 350, these four lines will make it take the short way to 350 instead of winding around the long way to 350 degrees. That'll work more or less within 90 degrees of the zero. More or less, I think there's a one-off error there. Then, if the frame does not equal the angle, it'll play the animated sprite in the direction that was determined by the true or false. The second argument of play the sprite is reverse. So reverse is either true or false. And by default, if nothing's given, no argument's given, it's false. And the animation plays forward. And if the frame does equal the angle, well, then the turret is pointing at the target and there's no need for the animation to play. So hopefully that makes it clear how the animation is built and set up in script to work in Godot. Later on we'll get back to the muzzle. For now we'll look at how the animation is created in Blender. So what we have is a turret. It's the only thing set to render right now, so it's only going to render the turret. All of the other pieces are set to not render in the visibility setting of the object properties tab. So we're only animating the turret. The camera is set up for the exact same view as when I animate the tank. So the tank can rotate its 8 directions within the field of view. The turret can rotate within the frame at all directions and stay within the frames. So we're ready to create the animation, and what we want to do is translate the animation 3D reality into the angles that are going to function in Godot. So when we rotate the 3D turret from pointing up the x-axis to pointing up the y-axis, it's 90 degrees of rotation in Blender in 3D space, but in isometric space, for that rotation, it's actually 120 degrees of rotation. So we're going to start off with the turret pointing up the x-axis and insert a rotation keyframe for the turret. I'm starting at frame 10 because I have the tank tread animation down here, so it's the first round number I can start at. Now we're going to advance 12 frames. What we're going to do is simply count off 10 degrees per frame until it gets to the y-axis, the 120 angles. No rotation is going to happen. We're just counting off the measurement for the frames. So we go using the arrow keys 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So that represents the 10 degrees of rotation per frame. Now we're going to rotate Z 90 degrees. Oops, that should be minus 90 degrees. And enter, then insert a rotation keyframe. The next turn of 90 degrees for the 3D turret is 60 degrees in isometric terms. So we're going to use the arrow key, 10, 20, 30, 40, 50, 60, which advances the playhead by 6 frames. Then rotate the turret, Z, 90 degrees, and I forgot to do minus 90 again. We'll try to remember that next time. Enter, insert the keyframe for rotation. We'll come back to the playhead, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. Rotate 90 degrees. Rotate Z minus 90. Enter, insert rotation keyframe. So we're entering the keyframes so that each image will represent 10 degrees of rotation and translating the 3D into the isometric terms. So back to the playhead, 10, 20, 30, 40, 50, 60. Rotate Z minus 90, enter, insert, rotation keyframe. Now we take these keyframes, select them all, and then change the interpolation mode to linear. Now it's notable that the actual motion doesn't break down that simple and round, and there is some visual inaccuracy along certain angles because the motion of a turret around this shape is not linear, and this is sort of a close enough way to create the animation. So now what we would render for animation is from frame 10 to frame 45. And we don't render frame 46 because it's a repeat of frame 10. Once the images are rendered into a folder and loaded into the sprite for Godot, there is a need to reorganize the images, and what's done is images are pulled off of the back side of the animation and moved to the front side of the animation until the correct visual rotation of 0 is sitting in the 0 frame. So that's the breakdown on how to make the turret animation, and later on we'll get into how to make a bullet shoot out of the turret from any of these images, and that part is a fair amount of work. So until then, take care.